Everybody, by the end of this video, you should be able to use a technique called dimensional analysis to interconvert between SI measurements. Also, you should be able to use that same technique of dimensional analysis to interconvert between English and SI measurements. Dimensional analysis is a technique that allows us to use the units to set up the math problem in order to do conversions. I find that this way is much easier to use when we're doing really complicated problems, and by the time we finish the really complicated problems, it makes the easier problems even easier. We don't have to memorize which way we have to move the decimal point, or we don't have to know if we should add or subtract powers. Like it just becomes an easier way to do this. Now, you have some familiarity with the idea of dimensional analysis, because when we ask you to say, let's say, yes, how many seconds are in 2.5 minutes? 2.5 minutes, you do a little math, and in your head you're thinking, and you come out with 150 seconds. Well, that's dimensional analysis, because what you're doing is you're using a conversion factor. 60 seconds equals 1 minute. And then you do some math, and you let the units tell you how to do the math in your head. And then you do the math, and you get 150. So dimensional analysis is a way to let the units be your guide through a math problem. And that's really why I like using this. If you let the units be your guide, you'll never get a problem wrong. So let's do some kind of shallow end problems. We won't throw you off into the deep end right away, but here's some of the shallow end problems. Look, I even have some stuff already there. Let me erase this. So one of the things that I see students kind of getting wrong right at the beginning is they wonder what to start with. So let me tell you that you need to start with the number that's given to you in the problem. So the number that's in the problem in this case is 5.4 centimeters. So what I'm going to do is I'm going to set up a dimensional analysis problem. So we're going to say 5.4 centimeters before we do anything else. Then we're going to write a multiplication sign, and then this is part of a fraction. That's the line. That's the fraction line. Okay. Now, instead of saying multiply by some sort of fraction, what we're going to do is we're going to call this the X line. I can't take credit for it. Mrs. Silverman, my school next door neighbor, was the person who came up with this. And so the X line is the way we're going to convert anything. Okay? Anything from now until the end of the year for the rest of your life. Use the X line and life will be good. Now, the reason why we use a fraction is because we're going to let the units be our guide. We want to get rid of centimeters. Okay? And then eventually we're going to want to go to meters. If you look on page 26 of your book, you will find out that 1 centimeter equals 10 to the minus 2 meters. Okay? This is our conversion factor. That's really the only other thing that we need. Much like we just said in our example problem that we had 60 seconds in a minute. Well, this we get right there from page 26. And there's even more in the back cover of your textbook, and I'm sure you can Google a million different conversion factors. But now, once we've set up the problem, what we're going to do is we're going to put the unit that we're trying to get rid of on the bottom, and the unit we're trying to convert to on the top. Okay? And so now, why do we do that? Well, let me make a little aside over here. I'll put it in a different color, that way you know it's not part of the problem. But let's say we have a math problem, 5 times 3 over 5. Okay? When you do this, you can do 5 times 3 is 15, divided by 5 is 3, if you want. That's legit. But a shortcut is saying, well, that's 5 on the top here, because we assume that to be over 1. So 5 on the top, 5 on the bottom. They cancel out or reduce to 1, and then now we're left with 3. So the answer here is 3. Well, like we know in algebra, you can treat letters, variables, just like numbers. So here we have centimeters on the top and centimeters on the bottom, and they can cancel out. And what unit are we left with? Meters. There you go. Is that what we're trying to convert to? Absolutely. So now, once we have the units, we can let the units be our guide, and now we plug in the conversion factor into where the appropriate unit is. The number 1 went with centimeters, and the number 10 to the minus 2 went with meters. So we're going to put 1 with centimeters and 10 to the minus 2 with meters. Now you plug that into your calculator. And there's a calculator helps video so you can figure out how to do this if you're having trouble. And you'll find that the answer is 0.054 meters. Make sure I get the right unit. Okay, it's the only thing that's left. I did the math. I multiplied through and did the math. And the only unit that's left is meters. Perfect. If they don't cancel, you know you did something wrong. You had these two numbers switched and they needed to move around. But since the units cancel and you put the units with the right number right in there, life is good. Okay, well, we'll work through this next example a little quicker here. So now, again, we're going to set up the problem. 67.92 kilograms, Mrs. Silverman's X line. And then we're going to put kilograms on the bottom and grams on the top. This will obviously equal something. We go to page 26, and we find out that 1 kilogram equals 10 to the positive 3 grams. Now you plug that in. Okay, so again, you use the numbers with the appropriate unit. Kilogram is on the bottom, so we're going to put 1 kilogram, 1 kilogram, 10 to the 3rd grams. There you go. Everything's there. Now we can do some canceling. Kilograms cancel. Grams is the only unit that's left. And so you plug it into the calculator and you get 67,920 grams. There it is. Okay. Now, these are a little more difficult. Okay. Not a ton, but a little. And so here we're having units that both have prefixes. In our previous examples, both of them, one didn't have a prefix. So here they both have a prefix. So what do we do here? Well, again, page 26, we look up the prefix milli here means 10 to the minus 3. The prefix micro means 10 to the minus 6. If you look, there isn't a specific conversion factor for micro to milli. Now, if you wanted to, you can Google a conversion factor between micro and milli. That's fine, or you can go and you can do whatever. But here's the way I would do it so that you can learn to do this kind of rapid fire. Okay, so you have to subtract the new unit from the old. So where were we? Well, let me. So again, if we're going to set up the problem, it's 1.93 millimeters. That's our old unit. That's the one we're trying to get rid of. X line, millimeters go on the bottom. Micrometers go on the top. Remember, that's a Greek letter. It's funny, but it's like a backwards Y or something. Okay, and now we have to make up our own conversion factor, which we can by knowing all the powers of the metric prefixes. And so we're going to subtract the new prefix power from the old prefix power. So minus 3 minus a negative 6. So again, this is our old and this is our new, and that's going to give us 3. So what that tells us is that 1 millimeter, the old unit, equals 10 to the 3rd micrometers, the new unit. So now we have a conversion factor, and we take that and we can plug that directly into our problem. That's our conversion factor. So it's 1 millimeter equals 10 to the 3rd micrometers. Okay, so again, you do the math there. And put my answer down here. That way I don't have to delete anything. You get 1,930 micrometers. Again, number in a unit. Millis cancel. What we're left with is micrometer. Okay, moving right along. Here is 17 kiloliters with, and we want to convert that to milliliters. Now, you'll notice here that the only thing that really matters is the prefixes. This could be kilo anything to milli anything, and it's still going to work. So let's do it. Set up the problem. 17 kiloliters, X line. Put kiloliters on the bottom, milliliters on the top. And again, we want to subtract the new from the old. So the old power, let's write that up here, is 10 to the third. The new power is 10 to the minus 3. So 3, that's the old, minus a negative 3 equals 6. So that means that this is that 1 kiloliter equals 10 to the 6th milliliters. Make sure that keep me on, it's not millimeters, it's milliliters. And so now that we have our conversion factor, you just plug it in. Okay, kiloliter, 1 on the bottom, milliliter, 10 to the 6th on the top, and you do your math and you get your answer. 1,700,000 milliliters. 1,700,000 milliliters. Okay. What if the units are wacky and you have all these things that are super wacky? Well, let me just tell you that it's easy to kind of do this as soon as you know dimensional analysis. It doesn't matter what you have. Follow the same things that I have been doing. Okay, start with the number that's in the problem. Okay, 352 meters. X line. Okay, meters on the bottom. Rods on the top. I don't even know what the abbreviation for rods is. And then set it equal to something. Now, I just went to Google. And Google's really cool. I'm sure you guys all know about Google. Okay. And I found how many rods are in, I'm gonna find how many rods are in a meter. Okay. And so it says 1 meter equals 0.1988. I'm going to stop there. Okay. Rods. Make sure I squeeze that in here. There it is. So now, again, whatever it is, you can do it because it's just letting the units tell you how to do the conversions. So let's plug it in. What number goes with meters? 1. What number goes with rods? 0.1988 rods. Meters cancel. We do the math, and you come up with an answer. Okay, rods. Okay, and right now, should I do the math? Okay, I'm going to pause the video, do the math. So I pause the video, and there's the answer right in there, 69.98, almost 70 rods. Who knows how big a rod, like whoever uses rods anymore, but hey, whatever. Okay, so now you can see that the pattern is all the same. Okay, so now we set this at 53 grains. I don't know what this abbreviation for grains is, so I'm going to write it all out. We X line. We're going to put grains on the bottom. We're going to put milligrams on the top. Okay, and again, go to Google or the back of your textbook or whatever, and that's going to give you a conversion factor. Okay, I, again, went to Google and did something, and I actually looked up how many grains are in a gram. So I actually am going to introduce this to kind of get us. So I actually didn't look up going to milligrams. I looked up going to grams. So let me get rid of this, and I'm going to say grams here. So grains to grams, it turns out that it's for every 1 grain, make sure, one gram is 15.43 grains. Okay, so again, we do the math, do some multiplication, 53. Oh, in this case, now we have a number on the bottom. Uh-oh, I hope that doesn't screw anything up. It shouldn't, okay? 53 times 1 divided by 15.43, or 53 just divided by 15.43, and that's going to equal 3.435 grams. Now, the problem is that we didn't get to milligrams. We just got to grams, and this may happen to you. Well, we can get to milligrams because we can do another dimensional analysis problem. We can say 3.435 grams, and we can X-line it again. Okay, we want to go to grams to milligrams, and now this is looking up in the book. You look up in page 26, and you say that 1 milligram equals 10 to the minus 3 grams. Now again, because this is on the bottom, that shouldn't throw you for a loop. Okay, so what we're going to do is you do the math, and you get 3,435 milligrams is your final answer. So that's one of the things that makes this very, 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 very powerful in my estimation, is that you can pile units on top of units. You can do 4 or 5 or 6 unit conversions to get to the unit that you want to. And I will tell you that that's going to be something that you're going to have to do at some point. I'm going to assess you on is you knowing what the unit conversions are, and then you being able to do the math, either doing it using doing it once or doing it twice. So this would be the first step, and then doing a second step. So you're going to have to do that. But it shouldn't throw you for a loop, because as soon as you get the answer to this one, then you just put that answer, again, that's what's now given, put it here, set up your X line, and convert. It should be fairly straightforward. Okay, now, what if there are 2 units? So this is where it can get supposedly pretty easy. Okay, so you have a car, it's traveling 46 miles an hour. So it's only in the United States that we use miles per hour. The rest of the world uses kilometers per hour or meters per second sometimes. So again, we're going to start with the number that we're given in the problem, 46, and I'm going to abbreviate this miles. Now, miles per hour, now watch what I'm doing, per hour, that's HR, but it's per 1 hour. You're going 46 miles for every 1 hour. So now, if you look in the previous examples, there was only a number on the top. There was only a numerator. Now in this example, there's a numerator and a denominator. Guess what? We set it up just the same. Okay, but this one may take a little bit longer. Okay, but it's all still the same. We have to pick a unit, and we can only convert 1 unit at a time. So what do you want to do first? Let me put on my super special listening ears. Okay, so we'll do hours first. Now, I'm going to pretend that I don't have Google and I know how to do stuff with Google. So I'm going to do it super slow. Okay, so I'm going to go 1 hour on the top. Oh, I'm sorry, hour. And then I'm going to go to minutes on the bottom. So what do we know? For every 1 hour, there's 60 minutes. And then, look, hours cancel because they're on opposite sides of a line, just like last time, just because they have to be on opposite sides in order to cancel. One's on the bottom, one's on the top. So now, if we look, what units do we have left? Well, we're in miles per minute, and that's not going to get us anywhere. We don't want to go miles per minute. We want to go meters per second. So we want to go from hours to minutes, and then minutes to seconds, right? So we're going to put minutes on the top, seconds on the bottom, And what's the conversion factor for every 1 minute? It's 60 seconds. So now again, minutes cancel, and what unit are we left with? Seconds. So now we're going to do this math. So we're going to do 46 divided by 60 divided by another 60. And so this is going to give us 0.0127 repeating. Now what's our units? Be careful. What's our units? Miles. We haven't gotten rid of miles. Per second. Okay? So now we just need to convert miles to meters. And again, it's the same thing. You'll notice, I just dropped something. Just be careful. Okay. So I look in the back of the book and I'm like, oh, okay. I have a kilometers to meter miles. So that's good. So let's go here. So I'm going to take this number now that I have converted to miles per second, and I am going to go 0.0127. I'm going to make it 278. Okay, just because it's hard to put 7777 repeating in your calculator and get an accurate answer. So I'm going to put miles per second. I'm going to X line it. And then how many seconds? 1 second, right? If you need to put that in there. X line. We don't want to do anything to seconds. We're going to do something with miles. So we're going to put miles on the bottom. And I knew miles to kilometers. So miles to kilometers. For every 1 kilometer, it's 0.62137. Okay. Miles are canceled. So what do we have? Kilometers per second. We're close. Let's X line. Let's go again. Let's do it again. Now we just need to go kilometers to meters. So we want kilometers on the bottom, meters on the top. We go to page 26, and every 1 kilometer is 10 to the third meters. So we do the math now. So we take that and we divide by 0.62137, and then we multiply by 10 to the third, and you will notice that we get 20.56 meters per second. There it is. Okay, that's your answer. So you can have 1, 2, 3, 4, 5, 6 different dimensional analysis problems. Slow and steady wins the race here. Convert how you know. Okay. Now, if you go to Google and you find a conversion that is, miles per hour to meters per second, and it works, great. Do it however you want. But that's how we're going to do. Okay. So I'm going to challenge you. Okay. So here's what I'm going to say. I'm going to say that there's a snail. Okay. Imagine you have a snail here. I'm going to make a little snail. Woo. Okay. Hi. He's a happy little snail. Okay. And that snail wants to travel to the next town over. Okay. That town is a long way away. Okay. Now, the snail can travel at, let's say, 3 furlongs per 1 fortnight. Okay. What I want you to tell me is how fast is the snail going in meters per second. Okay. Now, I will tell you that there are 14 days in 1 fortnight. And there is 8 furlongs in 1 mile. Okay. And then once you get that, then you may want to convert to meters per second, however you can. Okay. So how fast is he going in meters per second? Okay, because that snail needs to get to that town. Okay, so pause the video, and once you pause the video, I will, then you can try it. I'll have your answer in 1 second. Okay, so I did the math. I assume you did too. So here is my work. Okay, so furlongs per fortnight, I chose to do the time unit first. So this is on the bottom here, so it has to go on the top there. So we go through. The only thing that's weird is that there was so many things that I had to do that I had to bring this down. Once I did that, you get this in furlongs per second, super tiny number. And then that, you go furlongs per second to miles, to kilometers, to meters. You do that math and you get this as your answer right here. Okay, keep working on it, seeing if you can get it right. Okay, thank you. Hopefully you know how to use dimensional analysis now. Goodbye.